This is the video that goes along with the key for the Describing and Measuring Motion Practice Problems document. I won't be going over this entire key in the video because some of it doesn't really need further explanation besides what is written in the case. So I'm actually going to skip the fill in the blank section and move right down to the speed calculations. So for question 7, it asks to find which runner has a greater speed. Runner A, who travels 600 meters in 60 seconds, or runner B, who travels 60 meters in 5 seconds. What you needed to do for this was calculate the speed for runner A, and then calculate the speed for runner B, and figure out which one had a faster speed. So runner A, we know, went 600 meters in 60 seconds, and speed is distance divided by time. So we would do 60 meters divided by 60 seconds to get 10 meters per second. Runner B traveled 60 meters in 5 seconds. 60 meters divided by 5 seconds is 12 meters per second. So, because runner B went 12 and runner A went 10, runner B has a greater speed. That runner traveled more distance per second. Number 8 is asking for average speed. We know that average speed is just our total distance divided by our total time. In this case, this race car's total distance was 400 kilometers, and its total time was 1.5 hours. 400 divided by 1.5 is 266.6 kilometers per hour. Finally, number 9 asks us to find a hiker's velocity. The hiker traveled 400 meters south in 8 minutes. We have to remember that velocity has a speed and direction, so we need to add that direction into our answer. So velocity equals distance divided by time, which is our speed, plus direction. That gives us 50 meters per minute south. The next section is going to ask us to look at a graph and show work for any problems that require it. Don't forget that you did have notes that you could have looked back on. They're still there for you to view. The first question asked, what is the average speed of the object? It wanted you to round to the nearest 100. In order to find average speed, we need to take total distance and divide it by total time. Our distance will always be our y-axis. Our time will always be our x-axis. In this case, our distance is measured in kilometers and our time is measured in hours. So to find the average speed, we have to go to the very end. And the reason we go to the very end is because that's where they stopped. So our total distance is measured from the end. We know they started at 0, so in this case, wherever they ended, we don't have to do any sort of addition or subtraction, we just look at that number. So our ending distance was 14, so we know they traveled 14 kilometers, and our ending time was 16, so they know they took 16 hours. So 14 kilometers divided by 16 hours gives us 0.875, which we can round up to 0.88 kilometers per hour. Remember, our average speed is always going to take our total speed and our total distance, which is basically our ending point, if we don't travel backwards. So number 11 asks us to describe the motion of the object from 0 to 10 hours. So if we look here at 0 and we go up until we hit 10 hours, we see that it is a straight line that does not curve, and it's at a horizontal. That means that our object is going at a constant speed, and it's going away from our reference point. Number 12 asks us to describe the motion of the object from 10 to 12 hours. So here we have 10 to 12. We see that now our object has stopped. We know that the object has stopped because it is not at a horizontal anymore. It is not at a diagonal anymore. It's a horizontal line. Our distance does not change even though time keeps going on. 13 wanted us to draw a graph. So in this case, distance and time was labeled for you, and what you needed to do is plot it. So we have an object traveling at a constant speed away from a reference point, which is this first line here. Then they stop and return to the reference point at a constant speed. So that's what a graph would look like if you went away, stopped, and then went back toward your home or your reference point. The next one, you needed to put in your own distance and time. So you should have had units here. I left them blank because the units can be any unit of distance or time as you want, as long as your distance is always on your y and your time is always on your x. In this case, this object traveled at a constant speed away from the reference point, just like in our first one, but then did not stop and instead traveled right back to the reference point at a constant speed. So in this case, we have two horizontal, two diagonal lines that make a little bit of like a mountain peak at the top. And that's because they did not stop, so we don't have that horizontal in the middle.